I'll just start sharing my screen. So yeah, thanks for the introduction there. So I'm going to be talking about the work that I did during my research masters in 2019, which is at St Andrews. I did it with Will Cresswell, who was also my undergraduate supervisor as well. So I kind of ended up going to Cyprus completely by chance. We were chatting on the phone about potential projects when I was in the Hebrides, and it was lashing down the rain, and he said, "Oh, do you want to go to Cyprus?" And I was like, "Yeah, sounds great." So it was completely by chance I ended up there. So just put a bit of background to the study. So in particular, what is the post-fledging period? So we're talking about migratory birds here. And so it's the time from when the nestling leaves the nest until it migrates or disperses. So this is completely different from natal dispersion, which is the movement of a bird from its natal territory to its first breeding site. And in migratory birds, this period lasts between 2 to 3 months, and it ends with the commencement of their first migration in the autumn. It's an incredibly crucial time for a bird, as it's a time of intense selective pressure, and juveniles typically experience high mortality rates as they develop and disperse into novel areas. So they've gone from a really controlled environment within the nest to suddenly experience the outside world, feeding for themselves, experiencing predators and changes in weather. And but despite the fundamental importance of this period, it remains comparatively understudied in comparison to other stages of avian development. And this is because it's really difficult to track and observe young birds after they leave the natal area due to the large spatial scale they can range over. So something like a Blackburnian warbler has been found to move over 200 kilometers from its nest. So that shows the difficulty in tracking these birds. And it's also really important for population size in migratory birds. So in the European swallow, this stage of life controls their population size. So there's 4 main hypotheses which explain the movement in the post-fledging period. So you have the migration commencement hypotheses. So the movement by fledglings orientating in the direction that facilitates eventual autumn migration. So the Cyprus Wheatear, that would be to the south as they migrate to South Sudan, Eritrea and Ethiopia. The habitat optimization theory, which suggests that fledglings select areas to maximize access to food or to avoid predators. The homing target formation, which suggests that fledglings will seek out large landscape features that will help them recognize either natal or dispersal area during their spring migration. So this would be something like a big river valley. Again, in black-polled warblers in the US, they've done studies and you see them following river valleys. And then you've got the breeding territory prospecting hypotheses, and that suggests that fledglings search for potential future nesting territories by observing breeding conspecifics. So why go to Cyprus and why study the Cyprus Wheatear? I mean, obviously they're one of the best passerines going, but I'm a bit biased. But Cyprus Wheatear have been studied in the Troodos Mountains since 2009 by Will Cresswell and originally Maria Xenophontos. And then this work was continued by Rob Patchett, who I worked with, who was working on migration dispersal of Cyprus Wheatear using geolocators. So you can see in the picture on the left, you can see a geolocator on the back of this female Cyprus Wheatear. They make a great study species for migration and dispersal studies because it has a high annual survival rate for a migratory bird, along with a high breeding site fidelity for adults and low dispersal distances. So it's been a 10-year study, and the return rate of colour-ringed adults of Troodos is around 50%, and then juveniles have been found to breed in the year over a scale of about 0.5 kilometre to 2 kilometres from their natal site, and they have a first-year birds have a survival rate that may exceed 35% after migration. They're novel birds, so their migration to the wintering grounds takes 3 to 4 days and 14 days to return. And recently, there was a paper published from our work that shows that female Cyprus Wheatears sing. So it's a really tractable system because of the small distances that they travel. And then most juvenile Cyprus Wheatears that return to Troodos have been found to breed in the next year after fledgling, less than 1 kilometre away from their natal site. But this is a changeable measure. So onto the fieldwork. So there's a few nice photos of the Troodos field site here, and then Rob and Joe, who I was with out there in Cyprus with. So we're out there from March 2019 to August 2019. So we're working 6 days a week, morning and evenings, to avoid the heat of the day. And then, so yeah, I was saying there's 3 of us out there in Cyprus. So Rob in the middle, as you know, is Dr. Rob Patchett. So we're all assisting with Rob's PhD. So originally that's finding returning birds and then attempting to catch geolocated birds. And then I started my project in May time. And then we also had Jo Robbins-Kings out with us, who's Rob's partner, and she's a trained ecologist. Her help was vital, and she just did her own project on pollinators in the Troodos Mountains on the unique bee species up there, which she then did the same masters that I did the following year. So where is the field site? So for those of you who know Cyprus, it's on the highest mountain, so Mount Olympus. You can see the highest village here, that's Troodos village, circled in white. And then this is the main field site in red. So it's 130 hectare acre of National Forest Park at Troodos. And so it's about an altitude of 1,800 meters and has the Artemis Trail running through it as well as the Atlantis Trail. It's an old low density coniferous forest and it supports one of the densest breeding Cyprus Wheatear populations on the island. So when we first got there, I mean, I wasn't expecting this, but there was quite a lot of snow. So seeing Cyprus Wheatear in snow was quite a sight. And so the first challenge was the snow, and the field site is on a ski slope. So we first arrived, there was deep snow coverings, and the worst part of it was I'm quite a big individual, and sinking deeper than my knees in snow while trying to survey returning adults was a delight. So as the Wheatears returned to the Troodos Mountains, we produced a territory map, and then identifying colouring individuals and geolocated individuals for Rob to catch, and then put geolocators back on them. And so it's just an example of the northern half of our territory map, and that just shows the density that we were dealing with Cyprus Wheatear territories. You can see the dashed line, that's the Artemis Trail, you've got the road, and then the Atlantis Trail. So we would attempt to catch any unringed birds and ring them as well. So the first part of the fieldwork from May to June would be trying to find Cyprus Wheatear nests. So we'd be opportunistically do that through close observation of adult behaviour. So we'd watch some nest building. As you can see, this female in the picture on the left has a beak full of nesting material. Or if we weren't able to find the nest, as soon as I started feeding chicks, they were very obvious as to where they are. So they nest in holes in the ground, as you can see these photos on the right. Typical clutch size is 5 eggs and then 5 chicks. So this is the same nest. So you can see the blue eggs in there, and then you just see a little chick at the back in the top photo. So we monitor the nests every 3 to 4 days. And then as fledging approached, it'd be every 1 to 2 days. So it's quite a simple formula for Cyprus Wheatear. It takes them about 2 weeks to build a nest. Incubation takes about 2 weeks, and then fledging takes about 2 weeks. So the important thing to remember, my project was it was not possible to ring Cyprus Wheatear in the nest because access to the nest cavity would destroy the nest site. You can see here, this was a nest that I found when the female flew out the nest site, and I picked up a stone and you could see into the nest. So that was a great site, but still you wouldn't be able to reach into it. So there's potential nest predation from the Cyprus jay, so you see nest material ripped out. And then one nest which we had complete data for, we think was predated by a snake. So how did we catch the fledglings? So we catch them in their natal territory, and you can see, so that was so we knew what the parentage was, as you'd see parental care. So the first week attempt to catch them in mist nets, which was not particularly successful as they weren't interested in coals. So I ended up having to run around the territory trying to shepherd fledglings into a mist net, which, as I say, was not particularly successful. Then after 7 days, the fledglings started to feed for themselves. So spring traps the most effective way of catching them, as they're interested in the maggots. So you can see the colouring parents were being, and you could see them feeding the chicks. You knew the chicks were definitely theirs. So you'd have 5 chicks flying around the territory, and on average, the average date of tagging was about 13.5 days for the fledglings. So when we caught the birds, we take biometrics, so the photos of the ringing process here of a female. We take the wing length, the head and bill, and the tarsus. And all birds were ringed with a unique 4-ring combination. So there's 1 metal ring and 3 colour rings. And then onto my project, which was radio tagging the birds to follow their movements. So you can see here the radio tag on the back of the bird, and so this weighed 0.42 grams and had 13 centimetre antenna and a battery life of about 50 days. So the tags were attached using a modified leg loop harness. So the loop goes over one leg and the tag sits on its back, and then the loop goes over the other leg. And the harness was constructed of 0.5mm elastic thread that should naturally degrade, allowing the tag to fall off pre-migration. So birds on average weighed 15.8 grams when ringed, and the tags with the harness attached weighed 0.49 grams. That equates to 3.1% of the body mass. So as the typical brood size 5, we attempted to tag 3 out of 5 chicks and colouring the other 2 in the brood to see if there are any tag effects. So in instances where that ratio changed, so 4 birds were caught, 3 fledglings were fitted with radio tags and 1 with rings only. There were no tag effects. Birds flew off absolutely fine and fed absolutely fine after that, and they were seen dispersing at the same distance as the radio tag birds. So this is the first ever radio tag Cyprus Wheatear, called Bomb. So that was blue, orange, metal blue, and that one did one of the furthest dispersal distances. So the field site was split into 3. So the black is the main field site, and that was split based upon local topographic features. Each section was visited every 3 days, and we did random sampling. Each point I'd scan through the active frequencies using my antenna and the receiver, and any birds that were detected, I would then go find that bird, record its location in the GPS, and then return to the same sampling point if there are multiple birds to find. As it became obvious that birds were dispersing out with the main area, we added a 300-meter buffer, which is shown by the blue line. That was about after 4 weeks, and then after 5 weeks, it became clear that birds were dispersing even further. That's marked by the green line, so that's an additional 300-meter buffer. So that meant that every section was visited between 3 to 8 days during the study, and when you aggregated all the data together, that meant there was 15 discrete sampling events, and then individual birds can be recorded in different sections during the sampling event or not located. So for each bird, you could have greater or fewer than 15 locations. So on to the results. So there were 17 fledglings were radio tagged and 15 colourings from 19 different broods. There's a really high survival rate, which was minimum of 89%, which is almost unheard of in the post-fledging period. And we also found 3 clear periods of movement, so the pre-dispersal phase, dispersal, and then post-dispersal. And then birds start to disperse after 18 days post-fledging. So we had the maximum tracking time was 70 days post-fledging. So we had 21 birds dispersed from the natal territory, which settled within the study area. Away from the natal territory, we had 5 birds disperse and then go back to the natal territory, and then 2 birds didn't disperse. 5 birds of the tags failed, and then 4 birds moved completely out with the study area. We found 1 in the extended field site, which was over 1 kilometre from its natal territory, which confirmed this assumption. So the survival of Cyprus Wheatear post-fledging is incredibly high. Minimum 89%. That was from 4 individuals that could not be accounted for, either died or dispersed completely out of the study area. So a previous study by Will and Maria showed with colouring birds that survival was at least 95%. And the reason for this is there's a lack of predation, especially avian predators in the Troodos Mountains. Sparrowhawks are very, very rare breeders. I saw 1 attempt by a juvenile goshawk to catch a colouring bird, which was unsuccessful. And also there is a lack of inclement weather. There is no rain during the study period. The temperature is very constant, and there's an abundance of food as well. So those are the factors that normally cause death in the post-fledging period. So on to some graphs of the work. So this first graph is the average distance between all the locations for individual brood, and basically it's showing that as time progresses, birds become more dispersed within the brood. So birds within the same brood aren't clustering in areas. So that's basically showing the spacing between the birds. So that's calculated using all the possible distances between pairs of brood locations per week, and then taking means of that. So as I said, fledglings became more separated with age rather than more clustered, and they more than doubled their average distance apart during the 10-week study period. This graph shows a bit more nicely the 3 periods. So on the left, you've got the raw data, and and all the points are joined together, and it's the output of a general additive model. And on the right, it's the data that's being aggregated per week. So you can see a nice sigmoidal curve here. So the dashed line is the radius of the territory, and you can see as time increases, birds don't really move, and then there's a big movement, and then birds appear to settle again, which we think is a home range. So it's showing that distance from the nest increased with age before stabilizing, and so the model was a single term of days since fledging with a random effect of bird identity, and that explained 43% of the deviance. That was the best fit model. So these box plots show it even better, just how much the birds moved. So A is the mean distance traveled, B is the maximum distance traveled, and C is the standard error of the mean distance traveled. So the pre-dispersal phase, which is period 1, is up to 18 days post-fledging. Period 2 was 19 to 40 days post-fledging, and period 3 was 41 days post-fledging to end of tracking. So that's from 69 observations from 34 birds. So you can see period 2 is the largest area of movement, showing that the birds are dispersing away from the natal territory. Period 3 is a lot more similar to period 1, which indicates that they're settling in a location. So that's saying they're forming a post-fledging home range. So just a quick summary. So if we go back to those 4 hypotheses that I mentioned at the start of the talk, it's consistent with the breeding territory prospecting hypotheses. So this may enable birds to have earlier and more successful breeding the following year. And so the older juveniles ended up in areas where we observed breeding pairs in at least 1 year of the long-term study. So even though we didn't have enough data to create a home range map, it did appear they were forming these. And the following year, when Rob was in Cyprus with Joe again, they did see some birds return to the same area that I'd last tracked them to. So it does seem to support this hypothesis. So the breeding territory hypothesis does suggest that some juveniles at least will select in their year of fledging a breeding territory that's already in use by an adult based on the positive social information that, oh, adults breeding there, so we should breed there, it's a good location. And there was at least 22% of the juveniles to have their final location in territories where breeding was still occurring. And yeah, that's just a quick overview of the work I did for my master's. So it's been published in the Journal of Ornithology this year. It's open access. So if you want more information on it.
That's great. Thank you very much, Patrick, for cramming so much information into a 20-minute talk. If you have time, it would be great if you could post a link to that paper, so yeah, people could track it down. That'd be brilliant.